Okay, well, welcome everybody, and good afternoon. This at this GIRI Forum, we're considering the impact of climate change risk on the construction industry. As we consider these risks, we see the potential for increased error in adapting to the extreme circumstances that are coming along, and the opportunity we need to take to avert these risks that occur throughout the construction process, right from the we have to take account of it from the design stage right the way through the whole piece. I'm very pleased to be joined today by Daniel Keir, who is a specialist risk engineer, and Nicolette Botha, who is a senior technical risk engineer, both from Zurich Insurance. They're going to look at how widespread these risks are becoming and how they need to be addressed, particularly in the design stage, but also during on-site construction. I shall give a short introduction about GIRI for those of you who are not familiar with us, and then hand over to Daniel to lead the session. On the housekeeping front, can I ask you to mute your microphones if not speaking, but remember to turn back on if you're invited to ask a question. If you don't mind, please leave your videos on, because that way we feel the meeting has more vitality. Any questions as we go through, please use the chat box and we'll pick these up at the end. My colleague Eleanor is monitoring the chat box, and if we don't manage to get to answer those questions during the forum, then we'll record them and get back to you after the meeting. If you have any technical problems, well, being an IT expert, my advice would be to turn off and try again, i.e. leave the meeting and rejoin using the same link. So let's talk about GIRI. We were formed back in 2015 and carried out some research, and it's been a tough time for everyone, and firms have been forced to reassess overheads and budgets over the last few years, and as a result, investment in longer term industry improvement and training comes right under the microscope. Now, many of you may be familiar with GIRI to a sort of greater or lesser extent, but it's worth just reflecting on some key points about the origins of our thinking and our key messaging. Our original strategy for change, with the objective of generating a significant change in the efficiency of the UK construction industry through reducing the amount of errors made in construction. This research project we carried out in 2016, and these are the results that came out of that research. Error is costing the industry 21% of turnover. There's a direct cost of 5%. These would be the things we recognise on a sort of day-to-day basis, non-conformance reports and the like. 7% is unrecorded process waste, but there's also an indirect cost of 7%. This is where there's an impact on others, particularly in terms of delay and disruption. And the unrecorded process waste is where errors are made and they're either left and not corrected, but have an impact, or they're dealt with but not recorded. And then we have latent defects, which unfortunately affect the industry significantly to the extent of 3%. So this figure might be a bit higher or a bit lower, but it's the right order of magnitude. And if we think of the construction industry itself being contributing about 100 billion to GDP of the UK, then 21 billion pounds is being wasted per annum. And if an average construction company is making around 2 or 3%, we can see it's pretty much a no-brainer. We need to do something about it. The research showed that these were the top 10 root causes of error, and our activities following the result of the research have been targeted on these highest ranking causes. And you'll see in there, planning is top. There's quite a lot of design mentioned, excessive commercial and financial pressures, but particularly culture in the industry is a big issue. So GIRI's leading on thought leadership. We have training courses, campaigns and forums such as this one. We share knowledge through our research, which you can find on our website, social media and networking meetings. The benefits that flow from GIRI are the productivity gains, safety in that 37% of accidents occur during rework, sustainability, the avoidance of waste leads to a better carbon footprint, quality benefits are manifest, predictability, if we're not wasting time and money, our outturns are more predictable, and that will give us all a better reputation. So this is our strategic aim: to improve construction productivity and quality, reduce waste and costs by eliminating error. So that's pretty much the Get It Right initiative. We need to have the right culture throughout the industry so that people are empowered to act in ways which reduce error. We need to change the way we work and behave. And if we do that, we will have an industry that's more cost effective and has a better reputation. Now I'd like to hand over to Daniel, who's going to talk about the risks that we discussed earlier. Thank you.
Thank you, Cliff. I will go ahead and share my screen. Perfect. And into presenter mode. Perfect. Okay, so I assume you can all see my screen. Hello, everyone. I hope everyone is doing well. As Cliff mentioned, myself and Nicolette are going to be discussing the topic of climate change on the construction industry. So yeah, let's start with some quick introductions. I'll go first. I'm Daniel Keir. I'm a climate change specialist risk engineer at Zurich Resilience Solutions. So Zurich Resilience Solutions is the risk consultancy arm of Zurich Insurance, providing risk management services to customers that go above and beyond insurance. And we have several centres of practice, including cyber, supply chain, fire, several others, and climate change, which is the team that Nicolette and myself are in. Nicolette, do you want to introduce yourself?
So good afternoon, everyone. I'm Nicolette. So I'm working as a senior technical risk engineer within Zurich and working alongside our climate specialists. The role I'm mainly involved in is undertaking on-site risk assessments to get an understanding of the physical impact that climate and natural hazards could have on any kind of assets, whether it's employees or physical. Yeah, and been part of Zurich Resilience Solutions now for 10 years. That's me.
Perfect. Thank you, Nicolette. Okay, so moving swiftly on. So introducing the topics that we're going to cover today. So we're going to start to talk about climate change and how climate risks are evolving both globally and in the UK. And then we're going to move on and link that to the construction sector and talk about why we feel it's important to consider physical climate risks at the design stage of construction projects, but also we'll talk about some of the climate impacts at the actual on-site building stage, as Cliff mentioned before. And then finally, we'll move on to talk about how insurers and how Zurich Resilient Solutions are supporting businesses to build climate resilience. So straight into the climate change and climate risk piece. So some of you may have seen on the news last week that the IPCC, which is the Intergovernmental Panel on Climate Change, which is essentially the global body covering climate science and climate policy. So they released last week their latest report, which is a synthesis report for the public and policymakers to summarize latest climate change science. And this was one of the headline graphics from the report, and it develops the climate stripes, which were created by a scientist called Ed Hawkins from the University of Reading. And this graphic shows the observed and projected global surface temperatures. So the observed from 1900 up to 2020, and then projected up from 2021 up to 2100. And we are currently at about 1.1 degrees centigrade of warming compared to the start of the 20th century. And we have a global target to limit warming to 1.5 degrees centigrade in order to avoid the catastrophic impacts of climate change. Ultimately, we don't know what future scenario we're going to follow. So the potential climate impacts are for sure uncertain. But what we do know, and looking at all those scenarios from very low up to very high, the world is going to get warmer, and that in itself brings heightened climate impacts from various hazards, which we'll go into in a bit more detail. So the report suggests that we're likely to reach 1.5 degrees centigrade of warming pretty soon, by early 2030. And then this graphic from the report shows how the maximum temperature, mean soil moisture, and precipitation are projected to change under increasing warming scenarios. Unsurprisingly, almost everywhere on Earth is projected to see increases in maximum temperature, some regions more than others. Regarding precipitation at the bottom, most areas are projected to see increases in the annual wettest day of precipitation, and that leads to impacts such as flood risk, especially surface level flooding or flash floods. And then regarding soil moisture in the middle, again, most regions are projected to change here and become essentially drier and reduce their annual mean soil moisture. And then that leads to risks and impacts related to droughts. And then this is the final graphic I've pulled in from the report, and it shows the observed impacts and losses attributed to climate change, which the IPCC has split up into water availability and food production, health and well-being, biodiversity and ecosystems, and then the category that is most applicable to the construction sector and to the built environment is cities, settlements, and infrastructure. And then we can see by those dots just below the icons, they relate to how confident scientists are in attributing that impact to climate change, and we can see that there's high or very high confidence that increasing damages from flooding and storms to city settlements and infrastructure are attributed to climate change, and therefore will likely increase in the future as the world warms. In terms of how this applies to the UK, we're seeing very similar trends from both a heat and a rainfall perspective, with drier summers and wetter winters predicted. So looking at last year, in 2022, we had the hottest year on record, both from an annual mean temperature perspective and from an individual day heat record, where some areas reached over 40 degrees centigrade. July last year, that was the driest month since 1935 for England as a whole, and in some regions it was the driest month on record. And yeah, we know the UK is also getting wetter from both a frequency and severity of precipitation events perspective. In fact, 2011 to 2020 was 9% wetter than 1961 to 1990. So that's a 10-year period compared to a 30-year period. So it's quite big, quite a stark stat. And yeah, based on those trends, buildings and infrastructure, they need to be adapted to be able to cope with changing conditions and more extreme weather. So moving on to the link between climate change and the construction industry, and why it's important at the design stage to consider physical climate impacts. Well, firstly, the UK government, their programmes around sustainability and climate change have so far very much focused on the transition risks, on decarbonisation, on reducing greenhouse gas emissions, on embodied carbon of buildings, and on energy efficiency. This is great, and this is needed in order to reach our climate mitigation targets within the UK. But not enough attention has been paid on the physical climate risks on buildings and the built environment, and around building resiliency to warmer, wetter, more extreme weather conditions. So that's what we're going to focus the next section of the presentation on. So I'm going to be referring to the REBA stages here, which breaks projects down into 8 stages, starting with strategic definition at stage 0, and all the way up to stage 7, the 8th stage, which is use. And the strategic definition stage is not about design, that's rather about project or practical details of the project, such as budget and location choice. And then stage 1 is about preparation and briefing, and so that's developing the project brief and carrying out feasibility studies. And then the project design really starts at stage 2 and gets more technical up to stage 4 before construction begins at stage 5 and the contractors come in. And then once construction is complete, it's then handed over to the owner at stage 6 and then moves on to stage 7. So we feel it's really the early stages where the building's design is being developed, to stage 2 to 4 or 1 to 4 sometimes, where there's most opportunity to design out weather-related and climate risks from the building. Because when the plans get submitted for planning, it's likely to be too late to adopt new resiliency measures into the building during the on-site construction stage. So measures would then have to be adopted at a later stage and have to be retrofitted in the future, which is inevitably more hassle and at greater cost as well. So when undertaking a physical climate risk assessment of a location or of a building site, it will highlight perils of elevated hazard. And so there are many different climate impacts that need to be considered, not just current natural hazard impacts, but future climate change impacts. And at Zurich Resilient Solutions, we measure and assess sites and locations based on these climate impacts, so flood, heat, precipitation, windstorm, drought, wildfire, cold, hail, and thunderstorm. And yeah, resiliency measures against perils of concern can then be incorporated into the architectural concepts, engineering designs, and general buildings designs. So, for example, if heat is highlighted as a high hazard for that location, then some measures that could be incorporated into the building design includes external shading. That's to reduce the amount of solar radiation that enters the building into the indoor spaces. Window film as well, incorporating reflective surfaces into the building as well will help reduce the amount of solar radiation that gets in. On the precipitation front, if a location has been identified as having a high exposure to precipitation risk, and then one measure that could be incorporated is green roofs that essentially act as a sponge and absorb rainwater and reduce the amount of rainfall runoff from the roof. Wind, if that's identified as a high hazard, then things that can be considered as the roof geometry. Different roof shapes, of course, are more susceptible to high wind gusts. From a flood perspective, there's several measures that can be incorporated, flood doors or windows. They can be put up if there's a heightened flood risk, and once put up, that they'll create a seal which will reduce and stop any water getting in. There's flood barriers, and these can be deployed by a person and locked into a preset channel. You have non-return valves, which can prevent water flowing back up waste pipes, automatic air bricks, tiling sections of a room to reduce water leakage. And there's other measures as well, more on kind of resiliency front, in terms of raising critical equipment, boilers, heaters above the flood level. So for each hazard, each climate impact, there's various resiliency measures that can be incorporated into the building. So I just wanted to shed light on a recent example of structural damage to a building as a result of extreme weather. And last year in February, Storm Eunice caused wind gusts to reach over 120 miles per hour in certain areas. And the O2 Arena's canopy, which is made up of PTFE coated glass fiber fabric, it was not strong enough to withstand the wind speeds that the Greenwich area experienced, and part of the canopy's fabric ripped off. And so what that caused was the venue to be closed for a week, and several concerts were postponed, and also the outlet shopping area was closed for even longer. And the UK was also hit by a couple of other storms in February 2022. And so what we're seeing and what observations suggest is that the frequency and intensity of European windstorms could increase in the future, and damage from storms will likely be exacerbated by compound impacts such as increased rainfall. And ultimately, current building codes and regulations do not address or incorporate future climate risks. They only really take into account past weather data. And so, building project owners and building owners really need to start incorporating future climate risk into their designs to reduce losses. So far we've spoken mostly about the design stage of construction projects, and how to incorporate physical climate risk early on. But it's not just the design stage, it's also the actual on-site construction, where physical climate risks need to be considered, as any sort of adverse impacts can cause project timelines to be delayed and then costs to increase. So I'm going to pass over to Nicolette, who's going to talk about the climate change risks to on-site building projects.
Thank you, Dan. So like Dan said, a lot of things to think about when you design, and I think there's a lot of measures that construction industries, architects, etc., are very much aware of in relation to making a building sustainable, but they don't necessarily think about, well, when we're actually on site and we're constructing, have we actually considered some of these future climate risks? And what we have found, and just what's shown from some of the past storm events that we've been experiencing, is one of the biggest impacts is the economic losses that can be suffered by the construction industry. And that's very much because you have a halt in operations, or employees cannot reach the locations, or the conditions are such that employees can't work in it, because there's no planning to actually identify what these climate hazards could be during the construction process. The other one is also the cost of supply chain, because if there's infrastructure impacts, construction materials may not reach the site, and all these things add up to quite substantial losses. I think when we're doing the Beast of the East, they were estimating that it was costing the construction industry about £1 billion per day due to workers not being able to reach sites and construction materials not reaching the locations because of infrastructure not being available. It kind of leads on to employees. I think within the construction industry, when you're building a property, your biggest assets are the employees, because it is still very employee heavy. It's not an automated process. There may be automation. And if you're not considering what the potential extreme weather conditions are, this could lead to injuries of employees, which impacts insurable claims, for example. But it's also conditions which you need to consider. So, for example, during the heat waves in July, the heat is such that if you've not planned and provided enough well-being facilities for your employees, they potentially couldn't actually work, which means there's delays in your construction process and resulting losses from an economic point of view. And same with extreme cold weather. And then it's also the whole infrastructure around it. So it's not just looking at where am I going to actually build that building, but also how are the employees actually going to get to the site? If we've got extreme weather, infrastructure is not suitable because trains aren't running or the roads are melting. These things also affect the whole construction process, because effectively without your employees, you can't continue your operations. The other one is equipment. So it's planning what type of equipment will be suitable for use in certain conditions. For example, your cranes, are they adequately designed to withstand certain kind of wind conditions? Do you need to adapt what equipment you're going to use? Also, things to think about is if equipment are flooded, because you've got vast amounts of equipment being kept on site. So if you're not protecting that adequately from the weather conditions, it's damage to those pieces of equipment, which again means you can't actually continue with construction. The other thing is also to think about is equipment that's on site, and that probably extends to waste, for example, as well, is how do you secure it? How do you keep it safe? So, for example, if you've got wind-borne debris, it could impact the buildings that you're working on, which then causes damage. So you could be at almost the end of the stage of the construction process, ready to hand over. You've got a massive wind event, and you cause damage to the building as a result of debris from equipment on site, and that again leads to substantial losses. The other thing is also if you don't look at how you actually secure waste, for example, and you've got water runoff, you could result in environmental impacts because of water ingress into the water courses. The other thing is, which I don't think we always think about, is lightning strikes. So the data is showing that thunderstorms and lightning is on an increase, and if you don't plan for that, you could again it could damage your equipment, but also the employees working on the locations. So going back to buildings, but basically, yes, in the design stage, you need to factor in the resilience of the buildings, because we do want buildings to be sustainable and still be standing in 50 years' time. So that needs to factor in, because you don't want to get to retrofitting things into buildings at a later stage. Structural instability, that comes very much with drought. The issues with soil condition, then you've also got the issues with extreme drought conditions followed by extreme rain conditions. If you don't think about these things, are your foundations going to be adequate? Are you going to get halfway through the project and the soil conditions have not been considered adequately, and how that will affect curing time for building materials? Concrete, if you've got very wet conditions, then it could affect it, and I suppose even in extreme dry conditions would affect it, depending on your choice of building materials. The other thing to think about is also water scarcity, so drought. If you are heavily reliant on water to actually mix your concrete or anything like that, if you've not thought about that, and we have got periods of high drought, which means the importance will be rather on providing water for people, not for the construction industry. So all these things need to be thought about. And then supply chain is probably one of the big challenges, because if your suppliers are affected by weather conditions, you will be affected, but it's also how do these products get to your locations that you're building on. So it's quite a lot to think about there when it comes to supply chain. It's fully understanding the whole supply chain from the point of where the product is actually, or the materials are manufactured, right up to how does it get to your location. And also considering, are they thinking about how weather could impact them? Okay. So these are very much very high level kind of things that we think about. I mean, what you could say is you can break it down into each individual peril. It's like we looked at, there's 9 climate risks that you need to think about. But what we do find is none of them should be looked at in isolation. But quite often when you look at natural hazards as is, you kind of look just at flood or just at subsidence. But when it comes to climate risks, you do need to think about all of them in together rather than just at the individual ones, but also think about if you do have the extreme drought and then extreme rain, how will that affect your operations? Thank you. So just a look a little bit like we said, and so within Zurich Resilience Solutions, we put together our climate change and sustainability team within the UK, and the purpose of the team is very much to work as climate specialists like Dan, and also the physical on-site assessments like myself, and working together to fully understand what the physical impact will be on a location. So with that, we've built quite a range of services. All of these can be adapted according to our customer needs. So it's not always a one-size-fits-all. We do understand that, but this just gives you very much a high-level insight. I know it's a very busy slide, so please don't expect me to read any of it. So basically, what we do, I suppose the starting point is we'll do like we can do it as a global exposure analysis or very site-specific analysis. And what we'll do is based on the IPCC scenarios that Dan explained earlier. We can build an overview of what the future climate risks will be and how they will evolve over a period of time. And that can be done in 5-year increments up to the year 2100. But all these things are agreed with customers. But what that allows for is for you to fully understand what the specific location will be exposed to. It may be that you are planning quite a few different locations, so central London, and each of those, although you may think they will all be a similar kind of exposure, which is possible, because it's geo-coded, we can actually do quite a group portfolio kind of analysis, so you get full understanding of, and you can identify which locations are more exposed than others. So it's kind of what we call a global analysis. The next step, what we can do is desktop assessments. So you can maybe provide us with information on what the build is and what you're looking to incorporate and things like that. And we can do a bit of a sense check whether you understand the climate risks against it, whether you factor that in. For example, if you factored in that windstorm is going to become low to very high, or the flood depths can increase by 10% over a period of time. We also look at things like, are employees going to be impacted? And on the desktop assessment, we can give you a very high level kind of recommendations on factors to implement. Then we've also got the new construction support. That is very much, and they will probably work alongside our construction team who understand the materials you're going to use, but then also factor in the climate-related hazards. And that could quite often also be if you're selecting greenfield sites where you want to construct, so you know exactly what you need to think about in the future. Other words are physical on-site evaluation. So this could probably be very much on, you've designed everything, you've started your build, and we can come onto the site throughout the construction period and actually look at it and identify where you maybe need to think about certain kind of physical measures to actually mitigate. For example, are the crates secured adequately? Are your waste secured adequately? Have you put emergency response plans in place for employees getting to locations and things like that? So it's very much a thorough assessment of what's going on site. The Greenfield projects that very much fits in with the new construction support. It's just you're planning to build somewhere. We can give you some information around what is it that you need to factor in. And I suppose last but not least is supply chain value analysis. So we've got a supply chain specialist and he can do a full plot of your supply chain. So you fully understand what the supply chain is, but then on that basis, we can also put some climate data into that. And it allows you to also have a conversation with your suppliers to factor in if they've actually considered what climate could do to their operations. Because the last thing you want is you having a thorough plan on how you're going to mitigate, but your suppliers don't. And if they don't, it means your plans is almost void because you can't actually construct your site. So this is very much a high level overview. Like I say, we adapt and we can change according to our customer needs, but this is kind of a good overview, I think, of what we can do. Yeah. Over to Dan, just to wrap up for us. I'll take it. I think Dan, can't hear you.
Okay, I'm off mute. Okay, so yes, so to wrap up, I've got some concluding remarks just to summarise what we've spoken about today. So the first one is the fact that impacts due to climate change are becoming more frequent and more severe. We've seen that from various reports that are coming out. I referenced the IPCC report that was released just last week. The future is uncertain, and past events, they're no longer a suitable indication of future risk. And thus far, government-led regulation and building codes are very much focused around greenhouse gas emissions and reducing embodied carbon. But there's been a lack of focus on the physical climate risk exposure to buildings and to building sites. And with the climate changing as it is, this needs to be looked at. And so yeah, we feel it's the design stage of the project where there's the best opportunity to design out climate and weather-related risks from buildings and infrastructure. You can do a physical climate risk assessment study, identify what hazards your site is exposed to, and from that implement design measures to ensure that your building does not suffer from losses in the future, having not kind of carried out the assessment. But yeah, equally also during the on-site building stage, it's important to take into account climate risks in order to minimise delays and to stay on budget. So that's everything. Thank you very much. I hope you enjoyed the presentation. If you've got any questions, please fire away. I believe Cliff is going to manage the questions. But yes, if you've got any if you want to email Nicolette or myself about anything that we've spoken about today, about our services, I've got our contacts in the slides, which will be shared around afterwards, I believe.
Yes, we'll be sharing the slides. They'll be available. We haven't recorded this event. However, the slides will be there for you to look at.
Yes, we have. Sorry, we have recorded the event. It's been recorded.
Oh, well, we have recorded this event. I hope that we didn't say anything untoward. Anyway, moving rapidly on. We've got some questions here in the chat. And I'll just relate those to Daniel and Nicolette. The first one is, do any building adaptation measures for energy efficiency reduce the building resiliency from a weather perspective?
I can try and tackle that one. I would say that yes, a lot of the energy efficiency measures that are being incorporated into new buildings are focusing on insulation, on triple glazing, and that can actually lead to overheating of indoor spaces, and that can also lead to, if indoor spaces are getting warmer, then that could lead to a rise of issues like mold and damp, and then that has implications on the structure of walls and joints. So yes, I think especially on that insulation piece, there's potential impacts on how buildings are set up from a resiliency point of view. Yeah, I'd say yes.
I think, yeah.
Sorry, go on, Nicolette.
Yeah, to add to that is what it does highlight, and what it comes back to is that you can't solve one problem and not look at what else it can introduce. You need to look at the overall climate and natural hazards that exist, because if you just look in isolation, it could possibly introduce more problems.
Yeah, I think the unintended consequences come to bear, don't they? I mean, it happens in other areas of the construction procurement phase with what's called value engineering, where people think they've saved money or solved a problem, but all they've done is created a lot of other problems for someone else. So I think these issues do have to be looked at in the round. When I was in my design phase, designing buildings many moons ago, we always used to have to take into account an extreme, like a 50-year storm or a 100-year this, or part of the design would be you would factor in the extreme conditions. So are you suggesting that these regulations, these British standards that are used in design, need to be revamped to increase the potential severity of the 50-year or the 100-year storm? Or are you suggesting that it's the greater frequency that's the issue? Is it or is it both? What's your feeling on that?
Yeah, go on, Nicolette.
Yeah, I think that's the thing. What the O2 is a very good example of is when the O2 was designed. It was 20 odd years ago now, and it would have factored in maybe 1 in 100-year events or gusts of wind. What it didn't factor in is how this would change over a period of time, and it's specifically at that stage, climate change wasn't as much on the agenda as it is now, and also actually being aware that there is data out there now that it's constantly changing, so you do need to review it, and it is uncertain, but there is data now indicating that, okay, you could have a 1 in 100-year event, but that's based on historical data. What the climate data is forward-looking, and it could say, okay, well, this is the 1 in 100-year flood depth that you could have, and you could design to that. But what it's not looking at is how is that going to evolve over a period of time. And this is where incorporating climate data into it. It allows you to plan not just for the now, but for the future. So yes, it does need to change, and it does need to start focusing on that as well.
Yeah, we need to get the building regulations and standards to change to incorporate those future predictions. Then it's a little bit of crystal ball gazing, but I think the trends that you outlined at the start of your presentation are becoming more accepted as a means of designing our buildings. We have from Karen an interesting reflection that last summer, and you talked about water use. The water use went up considerably during the hot weather for a variety of reasons, including keeping dust down. So water use targets are all very well, but if the weather's that hot, you just can't avoid it, and it's something for us to think about.
Certainly, and I could add to that, because that's one of the things which very much is considering that, because the damage dust can cause just the equipment and the filtration systems is quite extensive. And if you don't consider that, you know, you are going to need extra water, or there's going to be extra dust because the drought and the heat conditions. And again, it comes back to that way I mentioned about the impact on equipment. And you know, if you don't have your equipment, what are you going to do?
Well, the thing, Nicolette, do you believe that? I mean, construction works have been going on in dry, dusty climates throughout the world, just not so much in the UK. Does it mean that the UK building industry will have to adapt to those types of building process that are used in hotter, drier climates?
Yes, definitely. And that's something just from other works I've done, is that you quite often find that we in the UK aren't used to these conditions. But I think what Dan probably could support is that the climate data is suggesting, you know, these conditions we've experienced last year, for example, is not going to go away. They say it's really explained, like with the heat waves and drought conditions. So yes, it does mean we're going to have to adapt in the UK. We have to find different ways of working and thinking about what it is that we do. And yeah, maybe go and learn from other countries where they're already using these kind of measures, because they are exposed to it. And then they could probably come and learn from us as well, because we're quite used to wet conditions, for example, whereas they maybe not.
So, Daniel, have you got anything to say on that?
Just to add on that, I know data suggests that by the middle of the century, by 2050, under a moderate climate scenario, a third of summer months are projected to be in that heat wave threshold of above 32 degrees centigrade. And so, yeah, so in the next 20 years or so, we could be experiencing temperatures that we experienced last summer much more frequently. So
we'll have to
definitely need to adapt our building practices.
We'll have to take steps to maintain our product, or to improve our productivity in those conditions, notwithstanding that we may be having a nicer time on the beach. So there's a question here from Gemma. What can design engineers do to create resilient structures when existing codes don't cover climate change? What would be some top tips for engineers?
Take it. I think this comes back to what we just explained, is your starting point will be what the codes are, but I think it's getting that climate change data from a company like or consultancy like ourselves, where we can actually get the information from the IPCC, so we can actually give you an idea of the climate scenarios over a period of time. So I think that the codes are now, and what a lot of the design codes are stipulating now is at least a building needs to be sustainable at least for 50 years, ideally, if not more. So the 30 years is not. So what that does is you've got a starting point for the design codes that's maybe say, okay, it needs to be adequate for 100-year event. But if you've got the climate data also obtained from someone, then we can actually show you, okay, well, over a period of 30, 40 years, this is how it can evolve. So whether it's increased wind conditions or whether it's increased flooding conditions, so you can factor these things into your design, and you actually know that you can have a structure that's resilient for future.
So what we're saying then is that at the moment we don't have this structure, shall we say, for converting current codes in a sort of methodology to get what we should allow for in terms of climate trends. And we can come to Zurich, or we can come to the IPCC, or whomsoever, but it's almost up to the individual designers to decide how to apply that data to their own design. And there isn't, I mean, I'm presuming some work is being done on this somewhere, and maybe it's a takeaway for GIRI, that we need to look into what is the the British standards, and what are these institutions doing about formalising a way in which the climate trends can be applied to design and specifications.
Yeah, I suppose there is legislation coming, and the thing is, and naturally legislation is mainly focused on the impact anyone's got on the climate, which is the most important, because if we don't reduce greenhouse gas emissions. But I think, for example, with EU taxonomy, they are starting to stipulate a little bit more on, you also need to think about the physical impact the climate could have, which would then start affecting regulations, because it's no point, you also need to make sure that whatever is being built or constructed is going to be future-proof, because it's also not sustainable if something is flooded and having to be rebuilt every 5-10 years. So it is coming, but I think if you start planning for it now, not just wait for regulations to be implemented, but also start thinking about it for yourself.
We've got a note here on the chat from Karen. It says, we use 2050 UK CP projections, whatever they are, aligned to TM52 and TM54, which clearly you'll understand better than me, and require BREEAM WUST 005 to be delivered in projects. It all sounds very technical. Do you understand all that?
I mean, I know that there are design methodologies for assessments of certain impacts, like overheating in homes. I think that's TM59. That set out, that incorporates some of this UKCIP future data, but as far as I'm aware, they're not incorporated into regulation yet. But yes, there are assessment methodologies for future impacts out there.
Yeah, I mean, BREEAM's been around for a while. I was building buildings to BREEAM. So is that being updated to reflect the current thinking on the climate change?
I suppose the 2050 UKCP, that is probably where it is incorporating, because it does say, okay, you need to think about that.
Okay.
The UK government's climate projections, but I think BREEAM is still also very much about efficiency of the buildings and things like that. It doesn't necessarily look at the physical impacts.
Yeah, Neil Gunn has suggested that, probably very relevant to this, that taking a risk-based approach according to the building's use, its location and the like, when deciding on which design standards to use or to extend. And just for note also, flood and rainfall standards set out in PPS 25. So it seems to me, looking at this, there are some various standards, or at least guidance, if not regulations, that people can look at. And what would be obviously a useful thing coming out from Zurich or GIRI together is some knowledge base or knowledge gathering of where these standards sit and how people can get to them, which I think would be very useful. I think the other thing that's very relevant that will help in getting these things picked up and dealt with is the mention of economic loss. You touched briefly on the £1 billion or that was being lost. I think was it daily on as a consequence of certain outcomes from last year. And I think that economic loss and the impact that'll have on the future of construction is particularly pertinent, and we need to be getting our brains around it. So I hope everybody, firstly, I'd like to thank Nicolette and Daniel for their input today. Very interesting and informative, and it just raises the bar, doesn't it, for us to think about the future and the potential for our industry and what we need to do about it. The error, the GIRI side of it, avoiding error. I mean, it's that thinking about things, doing something about it before the event rather than running around afterwards trying to put it right, where this sits very well with the GIRI message. So thank you very much for that, Daniel and Nicolette, and thank you to you who've come along today to listen and contribute, and hopefully you'll get involved again. We've got another 2 or 3 webinars coming up over the next few months on a variety of subjects, and look out for the GIRI website. It's very accessible and there's lots of information there. Thank you very much indeed.